physics, and after this we will end this class. Okay, so for today's question, the wavelength of first member of Lyman series. The wavelength of first member. This term is little bit important to find out the answer. The wavelength of first member of Lyman series is 1216 Armstrong. Calculate the wavelength of third member of Paschen series. Okay. So first know what do you mean by first member, what do you mean by third member. Okay. So let's draw this diagram. Suppose this is our nucleus and this is our orbits. Suppose this is n is equal to 1, 2, 3 and 4. So we know for Lyman series n is equal to 1 is our ground state orbit. Then remember n is equal to 2 is first member, n is equal to 3 second member, n is equal to 4 third member. If it is asking about Paschen series, so we know for Paschen series n is equal to 3 is our ground state orbit. Then third member become what? First member is 4, second member is 5 and third member is 6. So we need to find out the wavelength of third member, means wavelength between n1 is 3 and n2 is 6. Okay. So what we know, what we want to find, answer given wavelength of first member of Lyman series, lambda. First member of Lyman series means 1 to 2. 2 is our first member. So lambda 2 to 1 is equal to 1216 Armstrong. But what we know? We know lambda 2 to 1. Just do a rough work over here. 1 by lambda is equal to r into 1 by n1 square. Here n1 is 1 and n2 is 2 square. Okay. So this become 4. So it is 3r by 4 and lambda is 4 by 3r. So this is 4 by 3r is equal to 1216 Armstrong. Okay. So what we need to calculate? We need to calculate the wavelength of third member of Paschen series. Wavelength of third member of Paschen series, that is n1 is 3, n2 is 6. Then 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. Okay. This equal to 1 by lambda 6 to 3 is equal to r into 1 by 3 square 1 by 6 square. So this is r 1 by 9 1 by 36. So this is r into 36 4 minus 1. So this is 3r by 36, or this is 3r by 36. I am erasing this part. Okay. What we got? 1 by lambda 6 to 3, is it visible? Is 3r by 36. So lambda 6 to 3 is 36 by 3r. But what we have? 4 by 3r. So this become 4 by 3r into 9. What is the value of 4 by 3r? It is 1219 Armstrong. So this is 16 Armstrong into 9. So multiply the value, you will get 4, 5, okay. So this is your answer, 10944 Armstrong. Okay, clear? So next question, calculate the longest and shortest wavelength in Barber series of hydrogen atom. So longest wavelength and shortest wavelength, we need to find out longest wavelength, shortest wavelength in hydrogen atom. Suppose you are in exam and you have not exercised it, for which orbit to which orbit the wavelength is maximum and for which orbit to which orbit the wavelength is minimum. Suppose you have not exercised, how to remind it? Okay, we know energy E is equal to h nu. This means if energy increases, frequency also increases, but frequency is reciprocal of wavelength. This means wavelength decreases. Okay, and what we know, for infinite orbit to ground state orbit, the energy is always maximum. Infinite orbit to ground state orbit, energy is maximum. This means infinite to ground state orbit. Suppose for Lyman series 1, for Balmer series it is 2. So infinite to 2, energy is maximum, frequency also maximum, but wavelength is minimum. If infinite to 2 is wavelength minimum, this means 3 to 2 wavelength will be minimum. Sorry, wavelength is minimum infinite to 2, maximum is 3 to 2. So answer is very clear, simple. Here is the answer for Barber series. For Barber series, maximum wavelength N1 is 2, N2 is 3, then 1 by lambda is R into 1 by N1 square minus 1 by N2 square. Remember, never forget to write the formula while solving the answer. So 1 by lambda, this is maximum is R, 1 by N1 square, this is 2 square, this is 3 square. So this become 4, 9, 36. So this is 5R by 36, or lambda maximum is 36 by 5R. Okay, here we have the value of R, that is R is equal to 1.093 into 10 to the 7 meter inverse. Okay, its reciprocal value lambda max is 36 by 5 into R, 0.093 into 10 to the 7. So this become, we need to calculate this value using calculator. Okay, so I am giving up to you to find out the answer. Suppose you are in exam and you don't have calculator, so just remember 1 by r is equal to 0.914 into 10 to the power minus 7. Okay, or you just make it this equal to 914 Armstrong. Okay, this is the value of 1 by r. So here what we have, 36 by 5. So 36 by 5 into 914 Armstrong. 36 by 5 means this is 7.2. This is 7.2 into 914 Armstrong. So nearly multiply 7. 28. No. This. It's nearly equal to 6400 Armstrong. This is nearly equal to. Okay, you can calculate the exact value. I'm just taking the nearby value. Okay, so this is our lambda maximum. Similarly, minimum wavelength. Lambda minimum, 1 by lambda minimum is r into 1 by 2 square, Balmer series 2 square by 1 by infinitro square. Okay, so 1 by lambda minimum is r by 4, lambda minimum is 4 by r, and this equal to 4 into 914 Armstrong, because 1 by r is 914 Armstrong. This is 6, 5. Okay, this is minimum 3656 Armstrong. Clear? So this is maximum and this one is minimum. Okay, here's the answer. Okay, now the time for third question. You can have any kind of question related to this wavelength, like for differentiate, maximum wavelength belongs to ground state orbit to first member, minimum wavelength belongs to ground state orbit to infinite state orbit. Suppose it may ask you in like find the ratio between maximum wavelength of Balmer series to maximum wavelength of Lyman series, or find out the ratio between maximum to minimum wavelength of Lyman series, Balmer series, Paschen series, etc. So we can correlate this equation for different series. I am just calculating for any one series. Okay, like calculate the ratio of maximum wavelength to minimum wavelength in Balmer series. Okay, so here is the answer for Balmer series. For Balmer series, maximum wavelength, that is lambda max. Just we have calculated few seconds before. We got 36 by 5 r. Okay. Similarly, minimum wavelength lambda minimum, what we got, 4 by r. You can calculate it by using the formula 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. For maximum wavelength, n is equal to 2, n2 is equal to 3. For minimum, n1 is 2 and n2 is infinite. Okay. Then lambda max to lambda mean is equal to 36 by 5r into r by 4. R will cancel. This is 9. So this is 9 is to 5. Here is our answer. Okay. Or suppose I am changing this question. Find out the ratio of maximum wavelength to minimum wavelength in Balmer series with respect to Lyman series. Suppose I am changing this question to this question. So we have to change for Balmer series. Maximum wavelength is 36 by 5r, but minimum wavelength for Lyman series. So for Lyman series, minimum wavelength belongs to what? Minimum wavelength belongs to ground state orbit to infinite state orbit. So minimum wavelength n1 is 1 to n2 is infinite. Okay. So what will be our answer? Lambda minimum is r into 1 by 1 square. 1 by lambda is 1 by minimum. Lambda minimum is r into 1 by 1 square minus 1 by infinite square, or this become lambda minimum is 1 by r. So the ratio, so take this one as lambda Balmer and take this one as lambda Lyman. Just replace over here lambda Lyman, lambda Balmer. So lambda Balmer to lambda Lyman is 36 by r into r. So this becomes 36 is to 1. Okay. So you can do this type of question also. Okay. So within this we have done 2 questions. So it's time for energy. I am doing one question on energy. Okay. So here is our next question. Energy of an electron in an excited hydrogen atom is minus 3.4 electron volt. Its angular momentum will be what? Okay. Remember, if energy is given, this energy is our total energy. Suppose someone will asking you what will be the potential energy of the electron at this situation, what will be the kinetic energy of the electron at this situation. I am just adding. Find the potential energy and kinetic energy of electron under this condition. Okay. So let's do answer. What we have given, energy of electron in excited hydrogen atom is this much. Energy E is equal to minus 3.4 eV. Okay. So student, what we know, we remember, this is very easy to remember. We know for ground state orbit energy is minus 13.6 eV. For first excited orbit n is equal to 2, energy is minus 3.4 eV. It's very simple. We have just asked about angular momentum. So what we know, first we need to calculate for this energy what is the orbit number. We have the formula, that is minus 13.6 eV by n square is equal to minus 3.4 eV. So here n square is equal to minus 13.6 eV by 3.4 eV is equal to 4. So here n is 2. Then after what we need to calculate? Angular momentum. We know angular momentum. This is angular momentum. L is equal to nh by 2 pi or mvr. So this become n is what? 2 into 6 h given. H is 6.6 into 10 to the minus 34 divided by 2 pi means 2 into 3.14. Okay. So 2 cancel. 6.6 by 3.14. I am taking nearly 2 point something. This is nearly 2 point something. You can calculate that. Okay. Into 10 to the minus 34. Here angular momentum. Angular momentum. What is the unit of angular momentum? Okay. This is very simple. Here h n 2 pi. H unit of h is joule second. Okay. So this will be our answer. Then after I have added two more things, potential energy and kinetic energy of electron. So we know the relation that kinetic energy is half of potential energy, and here is a negative sign over here, and this equal to total energy with a negative sign. Okay. So here the given energy is total energy. Given total energy is minus 3.4 eV. Then kinetic energy is negative of total energy. This equal to minus of minus 3.4 eV is equal to 3.4 electron volt. Okay. Then after potential energy. So potential energy is minus of twice of kinetic energy. So this become minus 2 into 3.4 eV. This become 3.4. This is 6.8 minus 6.8 eV. So this is our potential energy. Okay. You people can calculate these values here. Okay, I am erasing this. So you just need to remember few formulas, a little bit concept, so you can easily do all kind of problem in atomic physics. Okay. For atomic physics, I am doing this much problem only. If you have any kind of doubts, you can just comment in my channel or just put some question over there. I will sure to do the answer. Okay. Thank you. For next class I will start one more new chapter.